Okay, so in this lecture, I want to briefly touch on nomenclature related to carbonyl compounds. That's going to be what we're going to be talking about for the next few lectures. So first of all, before we get into like IUPAC stuff, let's start talking about just what types of functional groups appear in carbonyl when we're talking about carbonyls in general. So carbonyl nomenclature. Let's first start off with just defining the typical functional groups that you see. We're going to be looking at aldehydes, ketones, and even though ketones is pronounced ketones instead of ketones, you don't throw a Y in there like K-E-Y, no. And then carboxylic acid derivatives. Now, carboxylic acid derivatives are going to be down the road a bit. We'll instead focus more on aldehydes and ketones. But carboxylic acid derivatives are where we have this sort of framework where the carbon is attached to the carbonyl carbon, which is then attached to some group, which could be Cl, Br, O, N, S, many things, just not H or C. Because when we have, in this case, X, when X is equal to to H, we have an aldehyde. And if it's C on both sides, then we have a ketone. Okay, so we have C on both sides, whereas the aldehydes have a C on either side. And maybe I should back up a minute and just say, oh, you know, a carbonyl, let's just back up for a second. Carbonyls are molecules with CO double bond groups, but it's also groups with a CO double bond. So we could say a carbonyl group or a carbonyl molecule. I mean, it could be the whole thing, it could be the functional group, or better yet, a position within a molecule. And this is the best use of carbonyl, where we say we've got some big molecule. We say, here's the carbonyl. And I'm referring to this carbon-oxygen double bonded system, not the carbon that I'm pointing at. That carbon would be the carbonyl carbon. We'll get used to this as we go along. Before we look at the IUPAC stuff, let's mention some common sort of some common carbonyl groups. Okay, there's the acetyl group. The acetyl group is when we have a CH3 attached to the carbonyl, which is attached to really anything else. So if it's an aldehyde, we call it an acid aldehyde. If it's like if it's a ketone, we have some sort of, like if it's a ketone, we have, yeah, let's look at this. So if we have an aldehyde on one side, then we have an acetaldehyde. If we've got a ketone where it's a CH3 on either side, we call it acetone or ketone. And if we have a carboxylic acid, we call it acetic acid. And the list goes on. This is a very common kind of functional group. And so we have that acet as opposed to calling the one on the left ethanaldehyde, because there's an ethyl group. It's an aldehyde, or 2-propanone for the middle one, or ethanoic acid. People, I've not heard ethanoic acid outside of like this one IUPAC lecture on carbonyls. So knowing the acetyl group is important. There's also the formyl group. So formyl is when instead of a CH3 on one side of the carbonyl, you've got an H on one side of the carbonyl. You might be like, well, isn't that just an aldehyde? Well, this is like a formyl group on the rest of a molecule, or you could name it as a full aldehyde. But it's helpful in some cases, like when you've got an H on one side, we would call that formaldehyde. If we've got an OH, so we make a carboxylic acid with that formyl group, we call it formic acid. But otherwise, it starts to, I mean, there are several examples. But if we try to get into carbon-based things, we wouldn't call that formyl butane. Instead, we would call that pentanal. So not formyl butane. So sometimes it can be a little awkward, like when we're naming ketones and that sort of thing, which is why the next thing to talk about really is kind of IUPAC naming. But before I do, maybe I should just mention again, the acyl acetyl is not the same as acyl. So acyl is just a generic term for a carbonyl with some sort of C on one side. Okay, there's other groups other than formyl and acetyl, like for example, there's benzoyl. If there's a benzene on one side of the carbonyl, and that helps us see benzoic acid and benzaldehyde and that sort of thing. But I don't want to go into that one right now. Let's just stick with our typical kind of, our typical two, which is acetyl and formyl. Okay, now let's do some IUPAC naming. It's important to kind of keep aldehydes and ketones separate as you're doing this. So IUPAC naming with aldehydes, what we're going to do is replace the ANE suffix with ANAL. Replace the ANE suffix with ANAL. So if you have hexane and you put an aldehyde on it, the nice thing about it is an aldehyde is it's always at the end of a chain because it has to have a hydrogen on one side. We would call that hex and now, not hexanal, that would be a little weird, but hex and now, and then for hex and aldehyde, thumbs down to that one. Sometimes people say that, but hexanal would be kind of the more appropriate one. And I mean, I guess you know, writing one hexanal I think isn't super helpful here because the aldehyde's always at the end of the chain. So often the aldehyde is C1. Okay, so what if it's not C1? You could argue. It's like, well, it usually is, but let's go ahead. Let's look at an example. So let's see, how long is this carbon chain? So I'm going to put it, let's just go through it and let's see. Okay, I'm just going to count this really quick down here. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I guess I drew a carbon chain that was 13 carbons long. Okay, with an aldehyde smack right in the middle. What we have to do is set this position to 1 and this position to 2 and then count either to the right or to the left so that we identify the longest carbon chain. In this case, it looks like it's the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the parent chain is no name. We're going to cross out the ANE and replace it with ANAL, so it's nona now. Now at the 2 position, we have a 1, 2, I'm going to do Roman numerals here, 3, 4, 1, 2, 3, 4. So we have a butyl substituent at the 2 position. Okay, so what we do is after identifying the longest chain, which was nona now, in this case, we have a butyl substituent, so we would call this 2-butyl because at the 2 position, we have a butyl chain, 2-butyl nonanal. Nonanal. Okay, so we've just identified the substituent, named the rest of the molecule as the parent chain plus A and Al, and then we have our molecule. Okay, so you could add chloros and that sort of thing. C1 is it's helpful because C1 is typically where that aldehyde carbon is, even if you have a bunch of chlorines on the other side. Well, I don't know. Okay, let's not think about all the ways we could get we could kind of confuse ourselves here. Okay, can't do all of the IUPAC rules within a single lecture. It gets to be diminishing returns quickly. Okay, ketones. Ketones are a little bit separate from aldehydes. Well, I mean they're pretty separate from aldehydes. First of all, we're going to have a different suffix on the molecule. Here we're going to replace the ANE with ONE for own, not one, but own. And we need the carbonyl position, because now the carbonyl is not at the end of the chain, it has carbons on either side. Okay, so let's look at some examples. All right, so in this case, we have a parent chain that's 1, 2, 3, 4, 5 carbons long. So this is a pentane carbon, but we're going to cross out the A and E and put own, and then we're going to put a 2 for the carbonyl position. Now, what does this look like when you merge this together? You have 2 pentanone. So that 2 is the carbonyl position. And that allows us to see the difference between the 2, the 3, and the 4 pentanone. All right, so here's 3 pentanone because we're right in the middle. Here's 4 pentanone. Wait, we can't do 4 pentanone because here we'll just number from right to left. Remember, always number so that we can give our substituents the lowest numbers possible. So this is just 2 pentanone. And you can see that if you compare the top structure and the bottom structure here, looks like the top structure has just been rotated this way. Remember, each molecule should have a single name if we're going to keep track of these things effectively. Okay. In ring systems, the ketone usually defines C1. Okay. So if the ketone usually defines C1, that's helpful, because if we have something like this, and we're not sure where to put C1, well, let's start at the ketone. Let's give the methyl group the lowest number possible. Then we have a 3-methyl. What's this? So the parent is a 6-membered ring. 6 carbons is hex, but we have a ring, so it's cyclo. Here we're going to have 3-methyl cyclo hex and own. Okay, so with rings, I guess we don't, shoot, I screwed that up. I screwed it up last year too when I did this. We don't replace the, just a quick correction here. We don't replace the A and E, we just replace the E only. I missed that last year too. Oh my gosh. Okay, sorry, I forgot that. I don't have a good excuse other than I just, after I tell you guys about IUPAC stuff, sometimes I don't think about it all the time. Okay. Anyway, sorry about that quick correction. Yes. So it's not the it's not the ane. It's just it's still an own, or you could say replace the ane with a known. Sorry about that. So you probably were looking at the parents that I was looking at already. Jeepers. Okay. Cyclohexanone. So anyway, let's veer away from the IUPAC stuff quickly. And anyway, just one last point here. What about an aldehyde in the ring? So aldehydes in ring systems. So what you do is you name the ring. Usually the aldehyde is C1. Usually the aldehyde is C1. Then add carboxaldehyde, this entire word. Okay, so what does this look like? Well, we have this molecule, all right? We have carbon 1 here. We don't have any other substituents to worry about, but we call this cyclohexane space carboxaldehyde. Okay, that's a little sloppy. Let me just bring this down here. I should have just deleted it. Space. Okay. There we go. So that's carbon number 1. If you add substituents, you'd add them and name it like how you would name a cyclohexane, and then you would call it carboxaldehyde. I suppose though, if we have other functional group numbers, now let's just keep it at C1. I'll select examples where that's C1. Okay. All right, so that's IUPAC stuff of carbonyl compounds. We'll get into the chemistry now as quickly as possible. So we'll look at that next time. Okay, we'll see you then.